In the lecture notes, I've given a bunch of definitions, and so I want to kind of show you what they are in the graphics. I think it's really, you kind of have to put them to the graph. So the first thing here, and the reason I have this partial graph here, is endpoints. Most of your graphs actually aren't going to really have endpoints, but if you have something that's a piecemeal, you will. So this here, you can see here at 2, 4, we have an endpoint, and that's the endpoint there. There is no endpoint on the other side. We have a minimum there, and we would have a local maximum here. There is no absolute maximum because, of course, this side goes to positive infinity. If we would have we would have had something like, well, let's do this. I guess it won't. It would make me do 2. I was kind of cheated. If like it had ended here, then I could have also had an absolute maximum. Okay. Then the other thing, I've got one graph that does most of it, but when we also have asymptotes, there is an asymptote here on the natural log graph here at y equals 2. I could actually make this dotted if we wanted to. There's my asymptote. And so, you know, it's hard to see here, but it never actually gets there, right? So that is our asymptote there. And so, you know, you might see those as well. But now, our new terms, those are all terms you've known before, you've used. But what we're going to be concerned with a lot in this class is increasing and decreasing. So when you read a graph, you read left to right, just like you read a book. And so as I read this, I can see this is going down. So this is decreasing. So I would be decreasing from negative infinity, because I'm out here on this, all the way to this minimum here. Now this graph would have no absolute maximum, but it would have a local maximum here at 1, right? Because that's the highest point in that area. So even if you don't have absolute maximums, you might have relative maximums. And so in this case, I have a relative max, but no absolute max. I do have an absolute minimum, though, because this is the lowest point. This over here, though, would be a relative minimum because it's the smallest area, it's the lowest point in this chunk of the graph. So I can have both, or I might only have one, depending on what I have. Okay? And then you can see here that after it comes out of this minimum, I have increasing. So I'm going to increase here from negative 2.9 all the way to 0. And then I would decrease again and increase some more. These changes in increasing to decreasing, the changes in which way my slope's going, are my critical points. So I have 3 critical points here. Those are the places where I change from increasing to decreasing or decreasing to increasing. So those are where my maximum and minimum, whether they're relative or absolute, can occur. Okay? Critical points are really easy to see because they're also maxes and mins, right? The other thing we have are inflection points, which are changes in concavity, and that's that dips and humps. When I look at this graph, see how this makes this, and this is kind of that parabola shape we're used to. This is concave down, okay? And then here, this hump, this is concave up. And then I also have here another concave down. So I have 3 areas of concavity. Exactly where it changes somewhere in here from concave up to concave down. We'll learn to solve for those inflection points, but it's harder to see. It's somewhere in there. Exactly where, though, it's hard to eyeball. You can't eyeball it the same way you can see there. But then about here, I would have an inflection point where I change from concave down to concave up. I would here again have another inflection point where I change from concave up to concave down. The other thing I would want to know is, of course, my x and y intercepts, and we're used to those, right? We've always been finding those, but those are still important for us now as we're doing this. But we're adding these new of inflection points and our critical points, which is the changes in this concavity and the changes in slope, in that increasing and decreasing. And that's going to help us sketch graphs by what we know about that. But as we're sketching it, things like intercepts are still going to be crucial because that's going to help anchor our graph in place as we work in those other pieces. So hopefully this helped you kind of put a face to all those definitions. We're going to be using those terms all semester, so it's important that you feel like you understand those terms.